Okay, so we have alternate forms of the derivative coming next. This one you have seen numerous times, the derivative at a particular value, but I, I want to talk about this one, and I'm a little disappointed there's not a place for me to do that. Um, so, all right, so I don't know. I want to draw, and then maybe I can do the work. So this thing I'm going to do right here. I want to talk about where this comes from. All right, how they did that. So let's say we've got a function over here. It's traveling along, and and we've got an a value. All right, so here's a. All right, and then this would be then f of a, just like before. All right, so just like we did on this one. But however, what they're saying is, well, we could just go to any value other than that, x, on the function, okay? And then that would put me here at x, f of x, and kind of talk about this the same way that we've been talking about it, okay? Of course, we're very interested in knowing what's happening here on the green. So we want to know the slope there. All right, and I always miss. And then, but this time we're going to approximate with something different. Instead of having an h that we traveled down, we just pick somewhere else on the function, okay, and we call it x. And so then we would have this line that we're going to approximate with. All right, okay. Well, then if we do this then, and we still do the y2 minus y1, let me get that green on there so you can see it. So this would be a f of a. Okay. All right, so y2 minus y1. Okay, here we're seeing that up here. All right, so y2 minus y1. And then the denominator then would be the change in x's. And this is what someone was asking. Do we always go to 0? And I was like, yes, most of the time. But on this alternate form, they're not. What they're doing is they're making this difference here, which is x minus a, x minus a, they're sending it to 0. So watch this. So if I say the limit as x minus a goes to 0, okay, well, x minus a would go to 0 if x and a go to each other. So that's what this is saying. So these are the exact same thing. All right, so you can kind of think of it as adding the a to both sides, okay, sort of. All right, not sort of, that's exactly what it is. So if I added the a to both sides, then x minus a would go to 0 if x went to a. Makes sense. If they're the same thing, then subtracting them would be 0, right? Okay, so that's the alternate form. And what's nice about that is it's a little bit easier to use than this one, okay, because there's less going on. That plus h there created a bit of a mess for you, okay? But if I go with this alternate form, it ends up just cleaning up a lot faster. All right, so here we go. So f prime of 1 then would equal. All right, so now I'm just doing this. So I'm going to have x approach 1. Now that's strange, right? But because we've not had that yet on the derivatives. We've had that on other limits that we've done. So we should be okay. So x approach 1. All right, and then it's going to be f of 1. No, f of x minus f of 1. There's the f of 1 over x minus 1. All right, let's see how this plays out. Now, of course, I can't do the direct substitution again, 0 over 0. All right, so let's do some algebra. So the limit as x approaches 1 of f of x, okay, in this case, it's the square root of 3x plus 1, okay, minus f of 1. If I put a 1 right there, 3 times 1 is 3, plus 1 is 4, square root of 4 is 2. And now you know what we're going to do. You know what we're going to do. All right, conjugate. All right, so multiply top and bottom by the square root of 3x plus 1 plus 2. And same on bottom. And remember, on the bottom, don't do it because you're really hoping that x minus 1, the x minus 1 right there is going to cancel out. So don't actually do it. We will on top, though. All right, so on top, we've got the limit. Give myself some room. There we are. Boop. So the limit as x approaches 1. All right, the numerator is going to be 3x plus 1 minus 4. And you're like, that doesn't seem good. Oh, no, it is. It's real good because there's going to be some factoring that we can do. All right, and so then the bottom, leave it alone. Plus 1 plus 2. Okay, now watch what we can do up top. So up top, that is 3x minus 3. Ah, that's really good because then I could factor out. All right, so that's a 3x minus 3. And so I'm going to factor out a 3 from that 3x minus 3, and then magic happens. So factor out a 3. Oh, and x minus 1 is so sweet. Okay, and then once that's happened, we can get rid of the x minus 1s, which are the really, really, really bad problem. And then we can substitute 1 in. So notice I'm not writing limit anymore because I'm substituting in. So the bottom then would be, oh, it's a little crazy, isn't it? All right, so that's okay. Yeah, if I substitute 1 in, I've got square root of 2 plus 2. Huh, okay, so be it. Which is a crazy answer. The square root of 2 plus 2. Okay. All right, but that's what we've got. I mean, because like everything looked good. Like what? Multiplied right here, minus the 4, which is really nice because that ended up being 3x minus 3, which I could factor a 3 out, cancel out the x minus 1. Yeah, that's wonderful. And then substituting a 1 in right there, it just is, it is what it is. No, it's not. Oh my gosh. 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 All right. Sorry. Messed up. I messed up a long time ago. Oh my gosh. All right. I'm fixing it now. All right. I'm not making a new video. All right. Sorry. This is, if we were in class, you would have told me that that needed to be a 3. All right. And doesn't change anything. That needed to be a 3. That needed to be a 3. I thought that answer looked really weird. Okay, clean this up. So sorry. Okay, back to the pen. I'm not making a new video. I just don't want to. Okay, so that was a 3x plus 1, right? Oh, gosh, so silly. All right, so that's going to be, if I substitute a 1 in, that's the square root of 4. It's 2. It's 2 plus, it's 4. 3/4. All right, that looks a lot better. Okay. All right, so yeah, if we were in class, you would have been like, oh, you left off a 3. Everything else was fine. It didn't mess anything up except for that denominator in our final substitution. Okay, so we needed 3s there and there. My bad. Okay, I'll let you know that there was a mistake before you guys. Well, you're probably doing it tonight. Never mind. Okay, I'll stop rambling.